In this example, we're told a 2.5 kilogram mass, which we're calling M1, is on a smooth surface. If there is a smooth surface, it means that there is no friction. If there was friction, then it would operate in the opposite direction to motion. We are told that mass is attached by a light inextensible string. Because it is a light inextensible string, it means that the tension throughout the system is going to be constant. We are told it's attached to a 1.2 kilogram mass, M2. The diagram is given to us. So it says the string passes over a frictionless pulley, so means there is no friction to consider in this problem at all. So it asks us to calculate the acceleration of the system. So what we need to do now is indicate all of the forces that are happening. I'm going to draw a force diagram for M1 and a force diagram for M2. M1 is sitting on the surface. Now, it has a mass of 2.4 kilograms. If there is a mass of 2.4 kilograms, then the force of its weight is operating downwards. So its weight would be represented by 2.4 g. Now, it is sitting on a surface, which means there must be a normal reaction perpendicular to that surface acting upwards. So I have drawn in the normal acting upwards. The string is going to have a tension in it. Now it is being held tight by the mass which is hanging over the edge of the surface. So there is T tension operating in that string. So I've marked T in my force diagram. The acceleration, of course, will be operating in the direction of the motion. The motion would be towards T. So what I can say for M1, we know R equals MA. We know T must equal 2.4 times A. 2.4 is the mass, A is the acceleration. This must be occurring in the I direction. We do not need to write down those vectors. The vertical movement on the particle is irrelevant because it's not moving vertically. We also know that the normal reaction must equal the weight. So in essence, they cancel each other out anyway. Now we're going to look at M2. M2 has a mass of 1.2. So there's a force of weight operating down, 1.2 g, which is on my force diagram. Going up through the string, there is T. So I've marked in T, the tension in the string. Acceleration, of course, will be operating downwards. For M2, R equals MA. The force is operating in the vertical direction will be 1 minus 2g minus T. That is equal to 1.2 times A. 1.2 is the mass, A is the acceleration. What I did in that step was I knew T minus 1.2 g equals negative 1.2 a. Because of the direction of motion, I then multiplied through by a negative and got 1.2 g minus t equals 1.2 a. Of course, if you know that is the case, you could skip straight to the step, as I did. Now we're going to solve our equations simultaneously. When we do that, I've got equation number 1 plus equation number 2. What I get is 1.2g equals 3.6a. Solving, a equals g on 3. G is a constant. G divided by 3 is a constant. So our acceleration through the system is a constant, meters per second squared. I can then take that value of A and substitute it into either equation. Obviously, equation number 1 is the easiest. When I substitute into equation 1, I get tension equals 4/5 g newtons.